Hello and welcome. Today we'll be going through the OptiAssist for Simcenter3D tutorials. This is the Composite Tutorial 2, Composite Box Section Ply Pattern Optimization. Here we can see that I've already loaded up the model. We are first going to run a simple analysis. From there we'll take a look at the results. From the perspective of the magnitude of displacement, we can see that the box does in fact bend under the given load. The peak displacement takes place at the end of the box at around 4 millimeters. Once you are happy looking at the results, we will click Return to Home and we'll begin the optimization. From here, we'll go to the OptiAssist tab and then click on Composite Optimization. This will open up the 6-tabbed optimization setup window. The first tab, subcase, will mean that we select the only load case. We'll then click Next. Under the Design Rules tab, we will create a new design rule. So we'll click New. We want the minimum plies and the maximum plies to be 0 and 10, which is the default. Therefore, we can press OK. We will then select all the plies and add the rule. We will now repeat the process, clicking New, and changing the type to Ply Patterns. We want the patch creation method to be grid-based, with the X for grid X be 1000, Y also 1000, and then Z 50. You will then expand the symmetry options and select the coordinate system. From there, we will now click Generate, which will create the 7 patches, each one consisting of 100 elements. We will now click OK, and again add the rule. We will now click Next. No further grouping is required. Under the goal, we will set the goal type to be minimize mass, to which we can then just say Next. Here we come to the Constraints tab, where we'll be making a new constraint. Click on Add. The response type will be displacement, with the upper limit being 1. We will select the node to be node 721. Click on Tick. Select load case and then OK. We can then click Next. Under the Settings tab, we will have the default settings for the optimization. We will change the max design cycles from 25 to 35. Click OK. We can now begin the optimization. Once that has ran, we can click No. Close the windows and check the design history. Here we come to the Constraints tab, where we'll be making a new constraint. Click on Add. The response type will be displacement, with the upper limit being 1. We will select the node to be node 721. Click on Tick. Select load case and then OK. We can then click next, and under the settings we will keep the max design cycles to be 35. We'll click OK. And we can then run the optimization. Once that has ran, we can close all the windows and take a look at the design history. Here we can see throughout the design cycles the mass has increased suddenly and then leveled out for the optimization. If we take a look at the constraint violation, we can see that initially it was violated, but then reduced to a number close enough to 0 that we can see is within the constraints. We can then close that and take a look at the thickness. If we go over to the thickness contour, load the results, cycle 35, now let's look at the total thickness, plot. We can see the thicknesses that have been added to the model, with the thicker parts being added at the bottom and the thicker laminates at the top. Once you're happy with that, we can close that, update the model from results, latest cycle. Remember to select all the layups and click OK. Once that is done, one way to check the new layups is to go over to the FEM file, under layups, select one of the layups and click edit. This will bring up the new plies, which you can check individually to view the new thicknesses, to view the new composition for the model. Once you're done with that, you can click cancel and double click back to the sim file, and that concludes the tutorial.